Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss chemical reactions of aldehyde and ketones. Last class I have discussed physical reaction of aldehyde and ketone. Now I am going to discuss chemical reactions of aldehyde and ketones. Actually many chemical reactions are there. Then I will try to finish it whatever is possible. After that I will continue in the next class. Then now I am going to discuss chemical reactions of aldehyde and ketones. Since aldehyde and ketones both possess the carbonyl functional group, they undergo similar chemical reactions. CO group is common in both, means in aldehyde and in ketones. Then first reaction is nucleophilic addition reaction. Here I want to discuss the mechanism of nucleophilic addition reaction. Mechanism of nucleophilic addition reaction. Then you know that the structure is, it is a planar structure. C double bond O, and with C other two groups are attached. Suppose one group is A, other group is B. Then what will be the mechanism of the reaction? I am telling you mechanism of nucleophilic addition reaction. A nucleophile attacks the electrophilic carbon atom of the polar carbonyl group from a direction approximately perpendicular to the plane of sp2 hybridized orbitals of carbonyl carbon. Here C and oxygen is double bond, then obviously that C will be sp2 hybridized. And here only you should know that carbon and oxygen is double bond, CO group. Then when bond will break, double bond, out of double bond one bond will break, means pi, when pi bond will break, then oxygen will take a negative charge, positive, and carbon will be positively charged, means electron will be taken by oxygen and it will become negative and carbon will become positive. This is a very, very important point to understand the mechanism. Then obviously nucleophile is negatively charged. Nu that is negatively charged nucleophile, like OH minus, Cl minus, Br minus. Then where it will go, now you can understand, because it is negatively charged, then it will go to the carbon of either aldehyde or ketone, because that will become, carbon will become positively charged and oxygen will become negatively charged. When bond will break, one bond will break, carbon will become positive charge, oxygen will become negative charge. The nucleophile will attack to the positive charge, means with carbon, it will attack to carbon. This is the important point. Then a nucleophile attacks the electrophilic carbon atom, means positively charged carbon atom of the polar carbonyl group from a direction approximately perpendicular to the plane of sp2 hybridized orbitals of carbonyl group. The hybridization of carbon change from sp2 to sp3 in this process, and a tetrahedral alk oxide intermediate is produced. Whenever nucleophile will attack to the carbon C plus, which is sp2 hybridized, then that carbon will become sp3, because 4 single bond it will form 4 single bond. Correct? That's why after when nucleophile will attack, then carbon will convert from sp2 to sp2 to sp3. That is a tetrahedral alkoxide intermediate. It will form. It will produce you can say tetrahedral alkoxide. The intermediate captures a proton from the reaction medium to give the electrically neutral product. Now, because on oxygen negative charge is there, on carbon positive charge is there, then nucleophile will attack Nu, which is negative, will attack to the carbon, which is positively charged, and this is actually intermediate. Now 4 bonds are there, one with nucleus and 2 with other group like A and B, and third is oxygen, which is negatively charged. Then now this negatively charged oxygen that will take H plus from the water, and this reaction, this step will be fast. First step, when it was a planar, and when a nucleophile attacked, that step is slow. Means step 1, when nucleophile will attack to the carbon, positively charged carbon, then that step is slow and it will form tetrahedral intermediate. After that, now it is a tetrahedral, but oxygen is negatively charged, and it will take H plus from the water. From the water it will take H plus, and this step will be fast. This is step 2. This will be the fast, and now O minus will convert to OH. Means addition product you will get. Means four can say groups are, first is Nu, second and third is the A and B, different group, and fourth one is OH. This is called addition product. Okay, then this I have told you, and this you finally got addition product. Now come to the reactivity. This is I told mechanism of nucleophilic addition reaction. Now reactivity I am going to discuss. Aldehydes are generally more reactive than ketone in nucleophilic addition reaction due to steric and electronic region. Question is asked, why aldehydes are more reactive than ketones in nucleophilic addition reaction? Then it is due to steric and electronic region. Sterically, the presence of two relatively large substituents in ketones hinders the approach of nucleophile to carbonyl carbon than in aldehyde, having only one such substituent. Electronically, aldehydes are more reactive than ketones because two alkyl group reduce the electrophilicity of the carbonyl more effectively than in former. Again, I am telling you, electronically, aldehydes are more reactive than ketones because two alkyl groups reduce the electrophilicity of the carbonyl more effectively than in former. In ketone, there are two groups, those two substituent group will be there in ketone. Okay? Keeping in mind, you can understand this point. Electronically, aldehydes are more reactive than ketones because two alkyl groups reduce the electrophilicity of the carbonyl more effectively than in former. Now, next point I am telling you that, but before going to the third point, here one problem I want to solve you, which is asked in examination, because this problem is based on this point only, reactivity point. What is the question? And question is that, would you expect benzaldehyde to be more reactive or less reactive in nucleophilic addition reaction than propanol? Explain your answer. Again, question I am reading you. Would you expect benzaldehyde to be more reactive or less reactive in nucleophilic addition reactions than propanol? Explain your answer. Then now you have to think benzaldehyde. You have to compare nucleophilic reaction with benzaldehyde and propanol. Propanol means it is also aldehyde, propanol. Then which one is more reactive, that you have to tell. And now I am giving you explanation. The carbon atom of the carbonyl group of benzaldehyde is less electrophilic than carbon atom of carbonyl group present in propanol. This point is important. The carbon atom of the carbonyl group of benzaldehyde is less electrophilic than carbon atom of carbonyl group present in propanol. The polarity of carbonyl group is reduced in benzaldehyde due to resonance. Okay, here in benzaldehyde, in benzaldehyde there will be resonance. There will be resonance means double bond will become single bond will become double bond. Why? Because CHO group is attached with the benzene, CHO group, then C and O is double bond. Then that double bond, due to this double bond, there is a possibility for resonance structure. It will be stabilized. Means C and oxygen double bond is there, then oxygen will take the electron, then that bond will be single bond, carbon will be positively. Then C and C of CHO and C of benzene ring, that is a single bond. Hence benzene double bond nearest to that carbon double bond is there, that bond will break. And what will happen after that? Now C carbon bond means C of aldehyde and C of benzene, that will become double bond. Correct? That will become double bond. And oxygen, that has taken its electron, and that is negatively charged. Then now carbon single bond now became double bond. And which was double bond nearest to the benzene carbon, that became single bond. After that, there will be complete rotation, complete, you can say, displacement of, you can say, this double bond. Double bond, it will break and electron will move to the next carbon. Like that way, rotation will take place. Finally, electron will reach to the, one pair of electron will reach to the carbon 6. Then again carbon 6 and carbon 1 will make double bond. Will make double bond. Correct? Then when there will be, you can say, a double bond, then now carbon-carbon double bond will break, and again C and O will be, which was now their single bond, now again it will become double bond. Correct? Then like that way, that is polarity of carbonyl group is reduced to benzaldehyde due to resonance. Okay. Hence it is a less reactive because it is stable. Benzaldehyde is stable. The polarity of the carbonyl group is reduced in benzaldehyde due to resonance, and hence it is a less reactive than propanol. In propanol, it is not like that. Now come to the third point, that is I will discuss here some important examples of nucleophilic addition and nucleophilic addition elimination reaction. Examples of what I discussed, on that basis some examples I am going to discuss, means examples of nucleophilic addition and nucleophilic addition elimination reaction. Now you can see addition of hydrogen cyanide, addition of HCN. Then easily you can understand HCN, this bond will break, then it will form H plus and Cn minus, and already I have discussed, that in carbonyl, carbon, when bond will break, carbon will be positively charged, oxygen will be negatively charged. Then now this HCN means H plus Cn minus, it will go to the opposite charged. Correct? It will go to the opposite charge, means H plus will go to the negative oxygen, and Cn is the negative, that will go to the positive carbon. Okay, then you will get, you can say cyanohydrin you will get, because H will go to the oxygen, H plus will go to the O minus, and Cn minus will attach to the carbon. But it will not go directly, it will go through tetrahedral intermediate. Already I have discussed, means carbonyl, it will form intermediate, means already two groups are attached there, substituents are there, and other two, now you can say this carbon will, this cyanide will join to the carbon, and C and O bond is single bond. Then this is the tetra, first it will form a tetrahedral intermediate. Already I have discussed tetrahedral, means now O is negatively charged. Now this is the slow step, and fast step is that now because O is negatively charged, it will take H from the water and it will form OH, means you will get cyanohydrin. Then direct way, what I told you, H plus Cn, directly you can write, correct? But I told you mechanism that before forming cyanohydrin, it will form tetrahedral intermediate. Okay, means H plus HCN has given H plus, that will go to the water, and water H will come to the O via media. Okay. Then I told you that this for formation of tetrahedral intermediate HCN plus OH minus, you can tell, hydroxyl ion, it forms first cyanide it will form, and OH minus will form H2O. Then this OH minus came from where? Then it came from the water. Okay. Then now first cyanide is produced, that will attack to the carbon, and oxygen will be negatively charged. And this step is slow, and when tetrahedral intermediate will form, the next step will be fast, means addition of H from water or proton from water, it will come and it will join to O. Then it will form cyanohydrin. Then I told you addition of hydrogen cyanide. Aldehyde and ketones react with hydrogen cyanide to yield cyanohydrins. This reaction occurs very slowly with pure HCN. With pure HCN, this reaction will take place slowly. Therefore, it is catalyzed by a base. Generally, because without base also reaction will take place, but it will take place slowly. But if you will use the base, then this reaction will go fast. Just to make it fast, it is catalyzed by a base, and the generated cyanide ion, being a stronger nucleophile, readily adds to the carbonyl compound to yield corresponding cyanohydrin. Okay. Cyanohydrins are useful synthetic intermediate. Okay. Now second reaction I am telling you, addition of sodium hydrogen sulfite. Addition of sodium hydrogen sulfide. Then here sulfite, ITE. Then here again same thing will happen, that is sodium hydrogen sulfite. Then sodium will be positively charged and rest will be negatively. Means NaHSO3 was there. NaHSO3 was there, sodium hydrogen sulfite. Then sodium will be positively and hydrogen sulfite will be negatively charged. Then again same way, positive will go to the negative and negative will go to the positive. Positive means CO group that will break, C will be positive, O will be negative. Then that it will attach, Na will go to the, Na plus will go to the O, it will form ONA, and now SO3H that will join with carbon. SO3H is negative, then it will join with C plus, but SO3 O will join to the carbon positive, or positive, it will join with positive carbon through O. Hence it will form that this in general way two substituents are there with carbon already there, and that now new bond form, that is with carbon and SO3H through O, and Na joined with oxygen. Oxygen was negative, sodium was positive. Then sodium joined with oxygen, then it formed ONA, and HSO3 joined with carbon. Then it will join through SO3H is there. Then through O, carbon will join with O of SO3H. Correct? And after that, second step, that is the proton transfer. Proton transfer means what will happen? SO3H is there, that H will come to that will exchange with sodium. In the place of sodium, H will come, and in the place of H, sodium will go. Only in the tetrahedral intermediate. Only in the tetrahedral intermediate, that's a proton transfer will be there. Means sodium will go to the H place, H will come to the sodium place, and it will form OH. When Na will go and H will come, then it will form OH, and Na will go with SO2. SO2 Na means OSO2 Na. This is called bisulfite addition compound. This compound. This is actually addition compound. Then this is called bisulfite addition compound. It is actually crystalline form. It is the crystalline form. Okay. The position of the equilibrium lies actually step 1. In step 1, when CO carbonyl group will join with NaHSO3, then that process means carbonyl compound plus NaHSO3, it will give the product, tetrahedral product, intermediate. That step is equal. You can say that step will be reversible. Okay. The position of the equilibrium lies largely to the right hand side for the most aldehyde and to the left for most ketone due to steric regions. That important point is there, that this reversible reaction I told you, then it is forming intermediate. If carbonyl compound is suppose aldehyde, it may be both aldehyde or maybe ketone. If aldehyde means then one H will be there and one substituted alkyl group will be there, like R. One R and one H will be there if it is aldehyde. Then if it is aldehyde, then reaction will be predominant. Means this equilibrium lies largely to the right hand side. Means it will form intermediate, tetrahedral intermediate. It will form more. Means equilibrium lies largely to the right hand side, means it will form more tetrahedral intermediate. And if it is a ketone, means now in the place of H another R is there, R dash, both R and R dash, and CO group is there. If ketone is there, then this reaction, reversible reaction, that will take left side. It will dominate towards left side, not to the right side. Means it will try to be in the form of ketone only. Okay. The position of the equilibrium lies largely to the right hand side for the most aldehydes and to the left for the most ketones. Why? And this is due to the steric region. In a carbonyl, two groups will be there. Two alkyl groups. But in aldehyde, only one alkyl group will be there. Okay. The hydrogen sulfite addition compound is water soluble and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkali. Therefore, these are useful for separation and purification of aldehyde. Okay. This step I am talking about the hydrogen sulfite. The hydrogen sulfite addition compound is water soluble. Correct? Hydrogen sulfite addition compound is water soluble and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkali. Therefore, these are useful for separation and purification of aldehydes. Okay. Now, this next reaction I am telling you, addition of alcohols. Actually, addition of Grignard reagent, already told you that also, because Grignard reagent RMGX, then this R minus, R will be minus, correct? RMGX, then MGX will be positive, R will be negative. Then here also it can attach in the same way what I discussed. Through tetrahedral intermediate product, it will join same way with Grignard reagent also. Already I have discussed 2-3 times. Now new reaction I am telling you, addition of alcohol. Addition of alcohol. But fundamental things will not change. Alcohol, then what it will form? Alcohol, ROH is there, correct? Then now that OH will be negative, R will be positive. OH will be negative, when it will break, OH will be negative, R will be positive. Then again it can join in the same way. Carbonyl group, oxygen will be negative. When double bond will become single bond, that time oxygen will be negatively charged, carbon will be positively. And here ROH, same way, OH minus R plus. Then it will go to the opposite sign, it will join. Okay, this you remember. And one more possibility is there, that ROH is there, then O and H bond also can break. Then that situation it will form H plus and RO minus, that is the alkoxide. Both you can say possibilities there. Then when you are studying this reaction, then both you can say, you can understand the reaction in both way, and product will differ accordingly. Then now I am telling you addition of alcohols. Aldehyde react with one equivalent of monohydric alcohol. Monohydric alcohol means only one OH will be there in that alcohol, in the presence of dry hydrogen chloride. Hydrogen chloride means HCl, it should be dry. Then this reaction, aldehyde react with one equivalent of monohydric alcohol in the presence of dry hydrogen chloride, and it will form to yield alkoxy alcohol. It will react with these things, alcohol, monohydric alcohol in the presence of dry hydrogen chloride to yield alkoxy alcohol. First it will form intermediate alkoxy alcohol known as hemiester. When it will form alkoxy alcohol, this is intermediate, then this is called hemiester, which further react with one more molecule of alcohol to give a Chem dialkoxy, correct? Chem dialkoxy, ALKOXY, Chem dialkoxy. If you will take two molecules of alcohol, okay, and it is called acetal when two alcohol will react, and when it will form Chem dialkoxy, two alkyl group will come, two alkoxy group will join, you can tell like this, alkoxy. Then that time it will be called acetal. Then hemiacetal means 50%. If one molecule of alcohol will take, then it will form hemiacetal, and if you take 2, then it will form acetal. Question is asked. Then the reaction I am telling you already in the beginning, I told what will happen. Then here aldehyde is there, suppose RCHO is there. Then now CH will be there as it is, C and oxygen double bond, that will break. C will be positive, O will be negative. Then ROH. Then what will happen to ROH? It will break into O and H bond will break. It will form alkoxide, RO minus, and H plus it will form, and it will join accordingly, means with the opposite charge. Then carbon is which is positively charged, OR will join there. O will join with this positively charged carbon of aldehyde. Okay. Then this is called hemiacetal, and H will join to the positive carbon. Oxygen. H will join to the oxygen because H is H plus, O is negative. Then H will join to the O, and OR, that O will join with the carbon. Then this is called hemiacetal. This is the intermediate. Now here again you can say that if another ROH is there, then what will happen? If another ROH is there, actually these reactions are reversible. Remember, both steps are reversible. Then now second step, suppose ROH is there, R-OH is there. Then what will happen to this? Then here that there is nothing new will happen, that OH is there. OH now bond is formed with carbon, then carbon and OH. In hemiacetal OH is there. This OH is attached to the carbon. That bond will break. Then again same way, or you can say very simple way you can understand that OH is there. Then that H, O and H bond will break. That OH bond will break. Then O will be negative charge, H will be positive charge. Then now when another ROH is coming, then what will happen here? That ROH, second molecule of alcohol, which is negative, R will be positive. Then now this OH bond, when it will break, then when H will go, O will be negative. Then R dash will join with O. R dash will, which is positively charged, this will join with the oxygen, which is negative. Then again it will form OR. O is joining with R, which is positively charged, from ROH, that R. Then again it will form OR. Then now see, this time now you got 2 OR bond is there. 2 OR bond formed. And this H from the OH, it went to the OH minus of ROH, and it formed water molecule. Then here 2 OR is introduced with aldehyde. That then it is called acetal. This reaction is very, very important. Okay. Now just think for the this thing, ketone. What will happen if ketone is there? Then here by reaction you can ethylene glycol, ethylene glycol, CH2OH, CH2 and CH2, 2 CH2OH is there, and both CH2OH is joined by single bond. CC is joined by single bond. Then CH2OH, again one bond is there, again CH2OH. Then here if reaction will take place with ketone and ethylene glycol, then what will happen? Now you have to understand. Okay, reaction is actually little complicated, but you can understand very easily. Very easily you will understand. Here you have to understand that condition first to understand HCl gas you required here. In presence of HCl gas, this reaction will take place. Ketone react with ethylene glycol under similar condition to form cyclic products known as ethylene glycol ketones. Ethylene glycol ketones. It will form ketones. Ketals. Ketal is coming. Name came by, you can say, ketone, because this reaction belongs to the ketone. That's why it is known as ketals. Okay, ketals, Ketals. Then product form is known as glycol ketones. Dry hydrogen chloride means HCl. Dry HCl protonates the oxygen of the carbonyl compound and therefore increases the electrophilicity of the carbonyl carbon. Here reaction we can understand that CH2OH is there. Then now suppose these two bond breaks, CH2OH, that now suppose bond CH2OH, that OH bond is breaking, then O will become negative, H will become positive. And now second CH2OH is there, then that OH suppose also it breaks, then now again this oxygen will get negative, hydrogen will get positive. Then now two hydrogen gone in the form of H plus. Then what it will do, this two hydrogen, then now these actually both ethylene glycol and ketone, suppose both are close, very close, they are about to react, then these two hydrogen will go to the carbonyl oxygen and it will form H2O. One oxygen will come out, CO, that both bond will break, oxygen will be free and it will have two pair of electron, because both one bond means one pair, two bond means two pair electrons is available on oxygen. Then there two hydrogen is there, then they will make two hydrogen bond, then to make the hydrogen bond two electron is required to make one bond. Then H plus means no electron is with hydrogen, then oxygen will supply, both electron will be supplied by oxygen, then it will form OH bond. Like that way one more pair is there of electron, that will give to the another hydrogen, correct, then it will form H2O. Now on carbon two positive charge will be there, because this bond is broken, two bond is broken, since two positive charge will be formed. Then now here what will happen, that CH2O minus, there are two minuses there on oxygen, then these oxygen also have one pair of electron, because when bond broken, OH bond, then H went, leaving their electron. Without electron it went. Oxygen has taken its electron. Correct? Then on both oxygen, one pair electron is there. Then now there on carbon, two pair electron is required, because two bond broken. Oxygen double bond was there, that broken. But now here two bond can be formed. Then now these two oxygen will join with the carbon by giving one pair of electron. Means with this carbon two oxygen will join separately. Then C and O bond will be formed. One bond CO, other bond will be again CO. Two CO bond will be formed. Correct? Then now see how CH2, CH2, O. OCH2, now it joined with carbon. Then now it is forming a ring, like a ring cycle. That's why it is called ethylene glycol ketal. Correct? And with ketone already two alkyl group was there, R and R it was attached, and that's why it is called ethylene glycol ketal. This reaction is actually very, very important, and a mechanism, I think now it is very clear that how they are breaking the bond, how OH is carbonyl group is breaking the bond, and how this ethylene glycol OH to OH bond is breaking, and how it is making bond with carbonyl. These two oxygen of ethylene glycol both are making bond with carbon. Because now two bond broken, then they can make a new two bond, and for this electron is required. Then that each electron will give one pair of electron to the carbon, hence it will make a ring. Okay, it will make a ring. That's why compound name is ethylene glycol ketal. 5-member ring, you can tell. It will form 5-member ring, and name will be ethylene glycol ketal. Okay. Now I am telling you these things. Next reaction, that is the addition of ammonia and its you can say these things derivatives. Then this reaction is also easy, because NH3 is there, then 3H is there, NH3, and on N lone pair of electron is also there, NH3, and one lone pair of electron is there on nitrogen, don't forget. Then lone pair of electron, now leave it. Then now in the place of H, suppose any other group is attached, like Z, any other group, then now it is called NH2Z. Then now this NH2Z, when it will react with this carbonyl group, then what will happen? The nucleophiles such as ammonia is a nucleophile, you know, neutral nucleophile, okay, because it is a lone pair of electron. Nucleophiles such as ammonia and its derivative like H2NZ, you can tell, add to the carbonyl group of aldehyde and ketones. The reaction is reversible and catalyzed by acid. The equilibrium favors the product formation due to the rapid dehydration of intermediate to form C double bond NZ. Now you can see in both reaction, either reaction with aldehyde or with reaction with ketone, same thing will happen, because on NH3, 3 hydrogen is there in case of NH3, then 2 hydrogen of ammonia and 1 oxygen of CO, both will react and it will form water, correct? Then now again you see that H2O, it will form H2O, then 2 bond CO bond will break, then 2 positive charge, means now this 2 positive charge will be created on the carbon, because 2 bond broken, C double bond O, correct? Means now you can say other, if they will get this electron from the nitrogen, 2 pair of electron, if you get electron from nitrogen, then it can make the bond. Then now you understand NH3, 2H bond, that bond broken. Then N is electronegative. Then hydrogen electron will be taken by nitrogen. Then now 2 pair of 2 bond broken, NH, and 2 pair of electron is available. Don't talk about the lone pair, that is already, it is not disturbed. Then this electron NH bond broken, then 1 pair, again another NH, again 1 pair. Then these 2 electron will be given to the carbon and they will make 2 bond, just like what I discussed earlier, kettle. In that case, here also they will form bond, okay? Then this bond, or you can understand this what I told you is directly, it will form actually 2, and this nitrogen will join to the carbon, because nitrogen is 2 pair of electron is there and carbon requires 2 pair, and C double bond it can form, and it will form, you can say, C and N double bond. It will form C and N double bond, but with N, either in case of ammonia 1 H is there, or if in case of derivative means Z is there, then NZ will be there. Z may be alkyl group, aryl group, OH group, NH2 group, correct? C65 NH group, NHCO, NH2, Z may be like this, okay? But it will form C double bond N Z. It will form this C double bond N Z, and with the carbon, when it is aldehyde, 1 air, either 1 R or 1 H will be there, or if it is ketone, both will be R or R dash, okay? Then I am telling you, suppose now if in the place of Z H is there, NH3, suppose in the place of Z H is there, then it will be NH3. That time what product will form? It will form C double bond NH. C double bond N and H will join. This is called imine. 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 Important. All reactions are important. Now I am telling you that what the value of Z, if a different Z will come, means sometimes alkyl, sometimes aryl, OH, NH2, 6,5, NH, NHCO, NH2, then what product it will give? Question is asked. Then if in the place of Z, if H is there, means reagent is ammonia, then you will get product, you will get C double bond N H, that is called imine. Product name is imine. Now suppose in the place of Z R is there, alkyl group is there, means reagent is amine, reagent is NH2R. You can tell NH2R, R is here in the place of Z, NZ was there, then in the place of Z, now R is there, means when it will react with amine, A-M-I-N-E, amine, then because now Z is R, Z in the place of Z you can write now R, then this is called substituted imine, that is the skip base, SCHIFF, skip base. Like that way, if in the place of Z OH is there, then it will form NOH, and it is called oxime. Just to place in the place of Z, you write this group, attach this group only. OH is there, then NOH, and it will known as oxime. Okay, means when it will react with hydroxyl amine, it will give oxime. In the place of Z, you write OH. Now next, suppose in the place of Z, NH2 is there. Then now in the place of Z you write NH2. Then it will be called hydrazone. Hydrazone means when carbonyl will react with hydrazine, it will form hydrazone. Better what I told you, in the place of Z, NZ is there, just to Z, what is the Z value you write. Then now if Z is NH2, then it will form hydrazine. But remember, NH3, one H is replaced with a Z. Is that you always remember, one N is already there. Then in the place of H now NH2 is there. Then it is that is when one is in the place of H, NH2 is there, then it is called hydrazine. That's why product will be known as hydrazone. In the place of Z, now you have written NH2, hydrazone. Like that way, if I can say this C65NH is there, C65NH is there, means phenylhydrazine is there. Then now in the place of Z, this group will attach with the N, Z is equal to now HNC6H5, means one benzene group is there and NH is there. That will come in the place of Z. Then this will form phenylhydrazone. Means with phenylhydrazine, it will form phenylhydrazone. In the place of Z, you have written NHC6H5. Like that way, if 2,4-dinitrophenylhydrazine is there, means in the place of Z, now 2,4-dinitrophenylhydrazine you have to write. Then 2,4-dinitrophenylhydrazine means in benzene ring 2NO2 is attached at 2 and 4 position. NH is there, with benzene ring NH is attached. With respect to that, or you can tell NO2 is there. Correct? Carbon number, you can say these things. Carbon number, okay, you count from the HN. Okay, then these things 1, 2, 3, 4. At fourth carbon, nitrogen, this NO2 group is there, and carbon number 2, NO2 is there. 2 and 4, NO2 is there. With respect to HN is joined with benzene, then it is called 2,4-dinitrophenylhydrazine. Then now it will come in the place of Z. Then now it will form already CN was there, now it joined in the place of Z, NH joined. Then it will form NH, 2,4-dinitrophenylhydrazine joined. Then product will be known as 2,4-dinitrophenylhydrazone. Okay, this hydrazine ZIN is converted to ZONE. Like that way, now suppose NHCO, NH2 is there, in the place of Z, you have to write NHCO, carbonyl group like that group is attaching, NHCO, NH2. This is called semi-carbazide. NHC and O double bond, then NH2. That is called semi-carbazide. Just like urea, you know, urea, CO, NH2, NH2. Then now one H gone, just to think like that. Then what is remaining? That is called semi-carbazide. Then now in this reaction, in the place of Z, now this semi-carbazide is joining. Then now it will form this CN was already there, with N now NHCO, NH2 joined. Then it is called semi-carbazone. Means 4 reaction is just very easily you can understand. Hydrazine will give hydrazone, phenyl hydrazine will give phenyl hydrazone, and 2,4-dinitrophenyl hydrazine again same thing will give 2,4-dinitrophenyl hydrazone. Means gene is giving you zone, Z-O-N-E. Last semi-carbazide will give semi-carbazone. Correct? Carbazide will give carbazone. Today I am stopping only here. Next class many reactions are there. I will discuss next class. Thank you.